1 students. This is going to be problem 1 of 5.2. It's identifying a direct variation. And notice how in that previous video I said that if you look at the direct variation equation, y equals kx, nothing is being added or subtracted from it. So when I'm trying to identify an equation, if it is going to be a direct variation or not, I'm going to be looking for that. I'm going to be looking for the fact that nothing is being added or subtracted from it. Okay? So does an equation represent a direct variation? That is our first step. Our second step is, if so, find the constant of variation. So our first example is 7y equals 2x. The very first thing we need to do is we need to get y by itself. So this is the very first thing you need to do in order to determine if this equation is a direct variation. So the very first thing you need to do is get y by itself. So let's refresh our memory on how we go about this. The very first thing I would do is I would circle what I'm trying to get by itself. I would circle the y. And then I would realize, hey, what is attached to the y? So we have PEMDAS. Please excuse my dear Aunt Sally, because we know that's how we solve things, or we simplify things, right? How do we solve them? By going in reverse. Well, what is happening to the 7 and the y? Good, you said it's being multiplied, you're correct. Okay, so how do I get rid of multiplication? By dividing it. So I can divide each side by 7. And I come up with y equals 2 over 7x. So that's our first step. So this all is part of step 1. Okay? Step 2 says, when y is by itself, does it fit the direct variation equation, y equals kx? Easy way of doing this is by putting the equation right underneath it. So I put y equals kx right underneath it. Well, does it fit the equation? Yeah, it sure does. The answer to part 2 is yes. Is yes, because there's nothing being added, and let's just say added or subtracted to x. Sorry, nothing being added or subtracted to x. Since nothing is being added or subtracted to x, y equals 2 over 7x is a direct variation. It is a direct variation because nothing is being added or subtracted to it. So then it says that if it is a direct variation, we got to find the constant of variation in the directions, right? Well, looking here, remember k is the coefficient of x. So if k is the coefficient of x, what is k in this case? What is the copilot of x? The copilot of x is 2/7. So therefore k is 2/7. The constant of variation is 2/7. All right, let's do another one. So again, we're trying to see if this is a direct variation or not. So what is our very first step that we need to do? Well, if you go back to our notes on the very first one, our very first step is to get y by itself. Okay, so we need to do that here. We need to get y by itself. Okay, so looking at this, again, I circled the y because I know that's what I want to get by itself. So I get y by itself, and the first thing I need to realize is what is happening to y. So what are the two things happening to y? Good, if you said that this was going to be, we're adding 4x to it, and we're also multiplying by 3, that is awesome. We are adding 4x to it, and we are multiplying by 3. Well, how do I get rid of that addition? By subtracting it, because remember the inverse operations. So we subtract 4x from both sides, and we get 3y equals 8 minus 4x. Why can I not add those together? I still have a lot of you guys who are wanting to add these together. Why can I not add these together? Because they're not like terms. Good, if that's what you're thinking, they're not like terms. All right, so I cannot add those together. And I got a question for you too. Is this really the proper way of writing this? No, it's not. Is it correct way? Yes, but is it the proper way? No. The proper way would be 3y equals negative 4x plus 8. Okay, so now we got to get rid of the 3. And we said up here that 3 was being multiplied. So what's the inverse operation of multiplication? Division. So I can divide everything by 3. And notice how I divided each term by 3. So I get y equals negative 4x, or negative 4 over 3x plus 8 over 3. So now our second part is to, now since y is by itself, does it fit the direct variation equation, y equals kx? Does it? If I were to write y equals kx under here, does it fit that? Does it fit that? No, it does not. No, it does not. And the reason why? Because 8/3 is being added to negative 3/4 x. Therefore, it is not a direct variation. Okay, since it is not a direct variation, there is no constant of variation, okay? I cannot answer the question about a constant of variation because it's not a direct variation, okay? So this is all you have to do. You have to tell me that this is not a direct variation. I do expect to see these steps. I expect you to solve for y. I expect you to tell me, yes, it is a direct variation because of whatever the reasoning is. And then if it is, I need to know the constant. If it's not, then you need to tell me, no, it's not a direct variation because why? Tell me why you have concluded that this is not a direct variation. So I put down here some examples of direct variations. Sorry again for the bump. So some examples of direct variations would be these. Y equals 3x. K is going to be 3. The constant is going to be 3. Y equals 2/3 x. K is 2/3. Y equals negative 1/2 x. K is negative 1/2. Y equals negative 2x. K is negative 2. Notice in all these cases, y is by itself, nothing is being added or subtracted from x, and k is the number in front of x. These are the big threes right here, okay? The big threes. Y is by itself, that's 1. You got to get y by itself. 2, notice if anything is being added or subtracted from x. If anything is being added or subtracted from x, then it is not a direct variation. But if there's nothing being added or subtracted from x, then we have a constant, and that constant is going to be right in front of x. All right, so I'm going to end this video, and I want you guys to actually try out. I want you to try out this problem. 4x plus 5y equals 0. And I want you to try out this problem. Negative 3y equals 6x minus 9. Try out those two problems and proceed to the next video. Thanks.